Welcome back to this series of videos about complex systems, modeling and simulations. In the previous video, we have seen the definition of what a complex system is, and we have seen this notion of model. And what I introduced was the fact that in the past, before Cosmo, people were using either a siloed model or data-driven model. Let me say a couple of words about these two situations. Siloed model. What is a siloed model? Well, look at the hand. Look at the problem we had with the hand. We said that we have to consider genes, cells, tissues, and all that together. Well, in the siloed modeling approach, you just consider all these subsystems and you forget the interactions between them. So you model the genes, you model the cell, you model the tissue, and you try to understand them separately. And after having done that, you're going to guess what happens when they're together. But you don't model the interconnections, which can be very complex. So, of course, you can imagine that it's a first step, but it's not very useful because you miss something that is extremely important in complex systems, which are interconnections. So this is the first way that has been used to consider to deal with these complex systems. Another way has been to use just data, to look at the data that you can have, well, about your hand or about any system, and look at what you can find in this data that can help you to understand what's going to happen. Let me give you a very simple example that I'm sure you already know. For example, you go to Amazon and you arrive on the website of Amazon, and just before you start to do anything, they make you some offers. And very often the products they propose to you, you're interested in them. You know why? Just because they have a lot of data about you. They have a lot of information. They know what you did in the past. They maybe know where you live. They know a lot of different things. So they have a lot of data about you. And since they have hundreds of millions of customers, they have a huge amount of data. And what do? They look at the people who are more or less like you, and they say, well, you're similar to them, so maybe you're going to like the products that they buy. So, and that's what they're going to offer you. So this can be extremely useful. I mean, it works very well for retail, for all situations in which you don't have underlying systems. Because as you see, we never consider a system then. We are considering individuals and data about them. So these data-driven models can be very useful in some cases, but they are not efficient in some way. The first way is in which they are not efficient is that they can only help you predict things that already happened in the past. It's because some other customers bought things in the past and that they look like you that they can make a prediction about what you're going to do. Unfortunately, for some systems, what you're looking for are not situations that happened in the past, but new situations. And the other thing is that there is absolutely no way with these approaches, data-driven models, to be able to explain the future, to explain the prediction. You can say, you're going to buy that, but there is no way with the model to know why you're going to buy that. You just know that some other people did the same, but you don't know that, well, you're going to buy that because it's your wife's birthday or because another situation. So you don't have the explanation possibility. At Cosmo, what we developed was something completely new, and we call that system-driven model, which means that we are not going to rely only on data, and we are not going to work in silos. We are going to work in a system-driven approach that will help us to know how the system is going to behave in the future, even if it never happened in the past. That's what we're going to discuss in the next video. Stay tuned.